is Yunfei Guo, and this is my ROS tutorial. First, I'm going to talk about how to create a ROS Catkin package, and here is a tutorial on ros.org. So, and I will use it. This is Ubuntu 14.04, and you can see I have already created a Catkin workspace, and I have already installed ROS. Here you can see the catkin create package, and that is the command that we use to create a package. And example is the package name, what package I want to create. For example, we can see here in my catkin workspace, in src, these are all packages, and so you just give it a name and what kind of message it includes. It includes standard message and also ROS.py. ROS.py is just Python that we use. We can also use CPPs and other things. So when we enter, it will create a package. You can see here, example is here, and like when we open it, it has a CMake list and src. So we have already finished create a package, and next we are going to look at how to write a rosnode. Rosnode basically contain a publisher and a subscriber. The publisher is just I have some messages and I just publish it to Ross, give it to Ross, and a subscriber, Ross just listen the message that you published. So here is the two files, talker and listener. I will talk about these two nodes. First, it import ROS.py and standard messages. When we write a ROS node, we just use it as a template, so we do not need to change it. And define a function. We can change it. For example, the one wants to talk it to make it talker, just like we can change it whatever we want. Talker, maybe. Just leave it here. And chatter, this is the topic. This is a ROS topic, and this is the message type. There are lots of kind of messages. For example, join state and string and sensor. This is just a message type, and this is the topic that we want to publish. So we can write whatever we want. For example, we call our topic example, and this is we initialize our ROS node, and this is the read, and that it will just operate. So in this string, what we want to publish? We want to publish hello world and the time. Maybe we can change it and just make it hello Ross. And this log info to this, it means that you put the informations into your variable, because you define the variable here. And pub.publish is that you actually publish your hello slash string, and you can see that pub is that you publish it to example. So here's our talker, and they're going to look at the listener. Also, these are the same, and we got a callback. Basically, this is the data that you need to listen to. And you can see here that subscribe, what we subscribe, it means we need to write example here because we just publish an example. And example and string means that what kind of message is it, and callback means that I want to, when I listen to something, I want to give it to callback, and callback is here. Rospi log info means that this is the object that we are going to display. So basically these are the listener and talker. I will show you some more examples later. I save it and I put it into Ubuntu. You can see that here is our workspace, and in src here is the example. We can make a new folder. It's called scripts. Did I spell it right? It doesn't matter what you call it, but you better name it as like scripts. And here we need to change the CMake files. You can see that the CMake files contains a lot of things, but what we need to do is just edit install. You can see here install programs. Scripts is the package name. We can change it if we just don't name it scripts here. But since we name scripts here, we don't need to change it. My Python scripts is like talker.py, and also we can have scripts listen, and we can paste our two files here. Wait. Okay, here it is. These two files, I can put it in scripts and make sure that the name is right. And we also need to delete and make it run. Say. And when we do ls, no, we need to cd to example. And when we do ls, you can see cd scripts. See that these two files, they are just writing y. It means that they are not executable. So if we want to cat king make, we need to make it executable. Let's see, change mode plus x listen.py, change mode plus x talker.py. And when do it, if we can see that it changed to green, means that we have already made it executable. And if we finish this, we can cd to workspace and cat king make. uh, IR node. You can see this node. It is almost the same. For example, import rospi, all this, but there are something different. For example, we import mass, and but that's not important and almost the same. You can see that you need to say need to define a message. This time uh, I use message type. Use a sign. Let's use a sensor import range. The message type is range, and I need to define the message type. For example, IR sensor range header is what, and type is what. This is all I define, and you can see it from ROS if you just search it. ROS range message. You can see it from here. Header, radiation type, field of view, all these things you can see from here. And also publish range. It's almost the same, and also log info into IR sensor and publish. So now I'm going to show you how to run these packages. We open a new terminal and we run ROS core. This is just run ROS, make ROS run in the background, and we open another new terminal. We can ROS run, and the next is the package name. I call it example. And next is the node's name. I call it talker. And I run it. It started gives, you can see hello ROS and the time. I open another new terminal and ROS run. Listener. You can see that it starts to listen to, you can see her hello ROS and the time. If I shut it down, Control C, you can see the listener, it does not listen to any messages. Next, I'm going to introduce you a very useful tool. You can use ROS node list to see what node is running. You can see listeners and talkers, that's my node. And you can also use ROS topic list, and you can see what topic is running. ROS out and ROS out AGG is just the ROS core made it. So that is my topic. And if you want to see that what topics in it and what is the message, you can use ROS topic equal example. You can see here it's giving data, and that's ROS hello ROS and the time. In this tutorial, I'm going to introduce how to use the GPIO using the Python library to drive the motor, and also how to read ADC. So I will show the tutorial that I'm going to use is the Adafruit library, and here are some tutorials about how to use GPIO, what is the command actually used. For example, if I want to use P810, this pin, first I need to import GPIO as GPIO and set GPIO out, and maybe set it high or low and make a cleanup. So I'm going to show how the motor driver works. You can see here is the datasheet of the motor. motor driver, and here it is, control function. In one, in two, PWM standby, and this is all the pins that you have on the motor driver, and you can see that if you set this GPIO high and this one low and this one high and high and high, it will drive clockwise, and otherwise you can see here it will drive counterclockwise. And I can show you some examples. First, you need to SSH to your BeagleBone, and since I do not have a BeagleBone now, so I just pretend that I have already SSH into my BeagleBone. I need to sudo Python, cause Python is Python you need to run as sudo users, so you can able to actually send messages to the pins. So after that, we can actually look at the pin out. So this is how we wired our motor. Here it is. You can see here that I use this graph. 3.3 volts is in, and this is a ground wire, and this is connected to motor A and motor A. These are two. This is actually two motor drivers. I mean, it can drive two motors. So we can just look at this one. It is PWM is here, and in one is here, and in two is here, and in one is here. So if we compare this graph with this one, you can see in one, in two GPIO. You can see that standby is always high, so we actually do not need to bother with it. So we just need to control pin in one, in two, and the PWM one. So this is how I drive the two motors. You can see from here, I import Adafruit as GPIO, and also import PWM as PWM. You can also see it from here. Import it from PWM. How to use PWM? Right here, it's like PWM start, and just PWM start, and this is the pin, and this is the cycle that you want it to be. Means that the maximum is 100 and the minimum is 0. When you set it to 0, it's like it stopped, and when you set it to 100, it worked as full power. You can see that set P14 GPIO out. P14 GPIO out. You can see P14 is PWM, and you need to set all of it out. It is just set up all this, and GPIO high and GPIO low means that P912. We can see from here P912. P912 is in one. So when we look at in one, when in one is high, and in two is low. In two is low. It's going to clockwise, and in my hand it means forward, but it may be different on yours. And PWM start. PWM start means that at is 50, so it means that I make it half the power. This is how I drive 2 motors. And also, if you want to drive 4, you can just copy and paste it, and you can write paste your code here and change all the GPIO pins, and it will drive 4 in 4 motors. So that is very easy. And let's look at ADC. So ADC is actually almost the same. Here is ADC setup and ADC read. It reads the raw data. The raw data from ADC is voltage. You need to change it. So you can see this is how to drive the AR sensor. But maybe the wiring is quite different, but it is almost the same. You need to set up the ADC and you need to read. It means that you read the raw data, and that's all. You can read from it and you get data from it. You can write your own node to drive your IR sensor or maybe other sensors.